What up, techies? Welcome back. If you are new to the channel, please subscribe as we are nerds for everything science and technology of the past, present, and future that makes the human experience better. Some exciting stuff has happened in the recent past. The James Webb Space Telescope launched into space almost 200 days ago from French Guiana with the extremely challenging task of detecting infrared light and generating high-resolution images. It has been difficult for researchers because anything that gives off heat, including the mirrors in our telescopes, gives away this radiation, making them imperfect tools at best to study celestial bodies up close or far away in the universe. But just last week, we found something special. A star system less than 24 million years old. With these new findings, scientists are optimistic about what they'll find once again when working on finding life elsewhere throughout the outer reaches. Let's take a look at these amazing images. The most detailed view before these past weeks was a photograph of the Southern Ring Nebula. It's located about 22,000 light-years away from us and provides an unparalleled look into how stars are born inside these incredible structures. The next two items on our journey through space take us to even farther distances. First up, the resection of 4 parts of Kit Nation, also known as HR81, which appears like some kind of immense cluster or collection of more objects in higher resolution than anything else in proximity at present. This is referred to as a planetary nebula, which is not the correct description of these heavenly bodies. They are unrelated to the planets in any way. However, because they are often spherical, early astronomers mistook them for planets due to their appearance, and the name persisted. These are clouds of gas and dust that red giants have ejected as they approach the end of their existence. In this picture, you can make out the several gaseous shells cast by the red monster. This particular image was captured by the near-infrared camera, also known as NIR-CAM, which examines the infrared wavelengths that are the shortest. Astronomers typically divide infrared light into 3 categories: near, middle, and far. This is because there are many different types of infrared light. And in point of fact, Webb's first 4 photographs are 7 images because 3 of the first targets were imaged with 2 distinct devices. This brings the total number of images captured by Webb to 7. The mid-infrared instrument, also known as MIRI, looks deeper into even longer wavelengths than the NIR-CAM, which captures images at wavelengths that are only a little bit longer than what we can see with our eyes. Because light can travel through clouds of gas and dust in the mid-infrared spectrum, it is now possible to see a great deal of previously concealed information. In the image that MIRI captured of the Southern Ring, it is possible to make out the 2 stars located at this system's heart. The more dimly lit one has evolved into a white dwarf. The brighter star is still in an earlier stage of its life cycle than the red giant that once dominated the sky. The red giant was the one that expelled all of the gas and dust as it approached the end of its existence. Hubble was also able to capture an image of the Southern Ring. Until recently, this was the best image we had available. It has already begun to fade into the near-infrared and is now beginning to fade into the mid-infrared. This is traveling around 4 times further away from what is likely the most stunning of the JWST's first photographs. This is a section of the Karina Nebula, located approximately 7,500 light-years away from Earth. This is a different kind of nebula, not a shell of gas flung out by a star that is dying, but rather a massive cloud of gas and dust actively forming new stars. Because it is one of the locations in our galaxy with the highest star formation rate, it is home to a vast amount of data about the process by which stars are created. The width of this image is approximately 16 light-years. It is a highly captivating architectural design. Astronomers have given it the name the Cosmic Cliffs. Massive young stars just outside of the visible frame attack the region with cosmic radiation, which erodes the dense wall of gas, while at the same time, hot, ionized gas flows into the blue area. In this section, we only want to show that every bright point of light that Webb images will have these 8 pointed stars, 6 large points arranged in a snowflake pattern, and 2 smaller points arranged horizontally. Diffraction spikes are what you see here. They are not an issue for science because the telescope can be turned such that the spikes do not obstruct a subject of interest. Nonetheless, they look cool and will forever be an immediate marker that an image is from the Webb telescope. This is the NIR-CAM image, but now we can move over to a smaller image that is a composite of MIRI and NIR-CAM. This image is an incredible example of how switching to the mid-infrared allows us to see through clouds of dust to what is beneath them. Naturally, Hubble captured images of this region as well. We can now demonstrate the progression from the image captured by Hubble to the NIR-CAM MIRI composite image, and finally to the image captured only by NIR-CAM. Also, we simply can't seem to get my eyes away from this one. Now is the appropriate time to ultimately depart from our galaxy. from zooming all the way out from a distance of 75 light-years to a distance of 300 million light-years. This is known as Stefan's Quintet, consisting of 4 galaxies that are part of a very compact local group, as well as a 5th galaxy that is actually in the foreground and is only 40 million light-years away from Earth. It's just a happy accident that it's also in the image. But that quartet of galaxies represents the most compact galaxy grouping that has ever been uncovered. 2 of them are currently in the process of merging, and ultimately, all 4 will come together to form a single entity. This is the largest of the initial photos produced by the JWST. It is a composite of more than 1,000 images. When counted all together, there are a total of 150 million pixels. You may easily zoom in on hundreds or even thousands of other galaxies in the background of virtually any part of this image, allowing you to observe not just the 5 galaxies that are currently in the front. When we switch to the MIRI image, we can see something that instantly jumps out at us. There is something very brilliant in the galaxy that is the farthest distance from us. This object is a supermassive black hole with a mass that is 24 million times that of the Sun. It is actively accreting more matter into itself and releasing more energy than 40 billion suns combined. Once more, Hubble has captured a photograph of this. Now we are transitioning into the MIRI image, and once we have completed that, we will transition into the NIRCam image. Now, our very last picture, which is, of course, the one that was taken the farthest away, shows a galaxy cluster. The galaxies appear as white blobs with bright spots in their centers when viewed from this vantage point. This is the picture's focal point, yet it's not exactly the main attraction. It's not so much this galaxy cluster that's interesting as everything else that surrounds it. What it makes possible is what it is. Its immense size causes depression in space, and when light travels through that depression, it is deflected. Additionally, since it bends light, it can magnify the light from faraway galaxies. Even with a telescope as sophisticated as the Webb, these galaxies are much too small to be seen with the naked eye. This phenomenon, known as gravitational lensing, has made it possible for us to construct a telescope that is 4.6 billion light-years in length. And here is another example of a deep field image gathered from the telescope. There isn't much room in this picture that isn't occupied by a galaxy, and many of them are extremely far away from one another. And in general, because the expansion of the cosmos causes light to be stretched out, resulting in a redder color, the age of a galaxy can be determined by how red it is. This teeny tiny crimson dot that we are currently focusing on, you should be able to spot it smack dab in the midst of that. That's right, we were referring to that incredibly tiny dot. 13.1 billion light-years separate us from there. We know you are as excited about these images as us. We can see new details and wavelengths from before 13 billion years ago, which were not visible with just one telescope alone. This gives us hope for what's yet unknown, and may even change how we look at things down here on Earth as well. Thanks for joining us. We really appreciate all the support. Please let us know your thoughts about the new images in the comments section below.